Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
R&D is embracing that we don't know what we're doing. We have an idea of where we are and we have an idea of where we want to be. But how we get there along the way is a little bit grayer, a little cloudier.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we are speaking with James Rogers. James holds a bachelor's degree in mechanical engineering and a master's degree in additive manufacturing and has substantial experience in both design and production. He's particularly interested in early stage product development and rapid prototyping technologies, and says that in a perfect world, he would spend his career putting humanity on other worlds and out among the stars. But in the meantime, medical device work is a great way to help humankind. James, thank you so much for joining us on the show today.
Thank you. It's great to be here.
So what made you decide to become an engineer?
Well, my story, I guess, is probably similar to quite a few others that have gotten into the engineering world. I'm not so sure that I chose the engineering life or the engineering life chose me. And I just kind of embraced it, but did some thinking about my core values earlier this year. My wife is a psychologist and was asking me about this. And one of the things we concluded was that if you boil down everything that makes me me, what it really all comes down to is solving problems. So for me, problem solving is what makes me tick. And so when you combine that with a passion for making things, starting as a kid with Legos and other building toys and then progressing into hand tools and more advanced things as you go, combining that also with the insatiable desire to understand how things work in general, just, starting with taking things apart and then eventually you're putting them back together again and they still work and to eventually you're making things from whole cloth. All of those things combined kind of describe what it is to be an engineer to me. And so I couldn't be anything else, really. It seems that that's the way it's shaken out. I actually, when I went into college, I started as a computer science major, as I thought I wanted to make video games. It turns out that making video games is not the same thing whatsoever as playing them.
Very different craft, huh?
It is a very different craft. I was ill-prepared for that, but I did get involved with the robotics team at the university when I was there. So as a naive freshman, I got to spend some time rubbing elbows with an emeritus professor and some really excellent senior students in the mechanical program that helps me find the path that I really belonged on.
Wonderful. I love that, starting with the core values and kind of working backwards from there. You have spent quite a bit of time doing R&D work. Do you think of yourself specifically as an R&D engineer or just generally as an engineer? And also, what do you think distinguishes the two?
Sure. I wouldn't say that I necessarily think of myself as an R&D engineer. But when you frame the question that way, it does make me think a little bit. I would think of myself as an engineer, but the distinction in terms, there is something there. And so, yes, I would say I am, in fact, an R&D engineer. The R&D to me requires embracing ambiguity and understanding that failure is a part of the process, whereas I think maybe engineering more broadly, that's less accepted and, expected even. There's a quote, I think, that's attributed to Einstein that's probably not actually his, you can believe everything you read on the internet, Abraham Lincoln kind of a thing, that goes, if we knew what it was we were doing, it wouldn't be called research, would it? And maybe Einstein said that once, maybe somebody else said that sounds like something he would have said, but it's definitely true. If we knew what it was that we were doing, then we would already have done it. And so R&D is embracing that we don't know what we're doing. We have an idea of where we are and we have an idea of where we want to be, but how we get there along the way is a little bit grayer, a little cloudier. And being able to embrace that ambiguity, take on that challenge, and then progress forward anyway, that's part of what it is to be in R&D to me.
I love that definition. Go ahead.
Thanks. Yeah, I was going to say failure, just to elaborate on that a little bit further, it's not necessarily a setback. It's an opportunity to refine our model of the universe in general, and more specifically to the problem that we're working on at the time. Some assumption that we have is fundamentally incorrect. And so understanding a failure gets us closer to the true nature of whatever it is that we happen to be working on at the time.
Wow. James, I feel like you said that an engineer is the only thing that you could be, but maybe a philosopher is something else that you could be. These are some deep thoughts. I really appreciate the thoughtfulness with which you're answering these questions. I'd love to dig more into R&D. You mentioned that R&D engineers really need to have a love for, or at least an acceptance of ambiguity. And I was working with a team recently, and it was very clear that this team of engineers, they were more sustaining engineers, not R&D engineers. And I don't think I've ever appreciated the difference as clearly as this recent experience, because there is very much a differentiation between the two. A sustaining engineer just wants to keep the status quo, which is great, right? If you have a product out there already and you just need to maintain a great sustaining engineer. But that is, a sustaining engineer will not and cannot do the role of an R&D engineer, because they're very different mindsets. As an R&D engineer, what are some of the most common challenges that you run into over and over?
Sure. Probably the biggest one, in regards to that ambiguity, a lot of people tend to fall into the trap of analysis paralysis, right? You spin your wheels. I don't know enough to move forward yet. And so you go out and you get a little bit more knowledge, and that just brings up a whole new range of things you don't fully understand. And you can spend, millions of dollars of government money and years of development trying to refine your model of what it is you're working on. When if you would just say, okay, we're gonna set a direction and we're gonna go and we're going to learn, failing fast, in other words, is a great way to break through that analysis paralysis. Another common challenge, I think, is kind of related to that, and that is the idea of the planning fallacy, right? The planning fallacy is this idea that we think we can plan for things. And generally speaking, people in general, we're terrible at it. If you ask somebody to forecast how long they expect to take a certain task, no matter how much they think that they are sandbagging in their mind, almost everybody is going to give you what is really a best case estimate. They don't know how to plan for the unexpected. And even when you know that that's true, and then you apply some, the rule of pi, we're going to 3x everything, it still isn't enough. There's been some interesting work done on that, looking at that problem. And, basically every engineering project winds up going a bit over budget or a bit over timelines because of this problem. So being aware that you don't know everything you need to know and then forecasting appropriately, that's often overlooked. Another common challenge, I think, is when we are working within a market that already exists. So it's not completely blue sky. There's some amount of historical information available. Unfortunately, sometimes that information is either incomplete or inaccurate and can be misleading when it comes to making decisions. So I wish that was less common than it is, but that does seem to be the experience I have had throughout my career. Probably not specific to R&D in general or in specific, but the idea of moving goalposts. So a lot of the times projects can get off track because what was established as this is your success criteria at the beginning, as you get 90% of the way there, management or somebody swoops in and says, aha, we are about there. Okay, well, guess what, team? We need you to plus alpha on this one.
Yeah.
And so, yeah. And that, I guess, ties into the last one I'll just toss out here, and the idea of office politics. This isn't specific to R&D, but a lot of people that wind up in R&D are probably like me, somewhat um, well, weird, non-neurotypical individuals. We don't think the same way that everybody else does necessarily. And so our ability to play the office politics game is even more difficult than the general engineering population. And I wish that was less the case, that it wasn't necessary. And I guess probably in a perfect company, it wouldn't be. But the reality is companies are made up of people, and people are inherently, tribal by nature. So it's going to be part of the game. You got to learn to play it.
That's a really interesting observation. I'm not sure that I've ever thought about it that way, where the mindset of an R&D engineer is not super compatible with office politics. I'm going to have to think about that a little bit more. And I don't disagree with it. I'm just going to have to think about that a little bit more. You've given me something to think about now, James. Thank you.
Yeah, you're welcome. It's the whole, well, for me anyway, I solve technical problems. That's what makes me tick. I really enjoy that aspect of things because I can manipulate the variables much more cleanly. My wife, as I said, she's a psychologist. She's a practicing counselor. The problems she solves every day are very different than the problems that I solve. And she's manipulating, manipulating is probably not a socially preferable word for that, but
doesn't need to have a negative connotation, right? The word manipulating.
Yeah. You're interacting with a completely different set of constraints in that domain that I don't have anywhere near the expertise to deal with.
All right, I'm coming back to this idea of R&D engineers not compatible with office politics, and I think I do have to agree with that. I just thought about core value number 2 here at Pipeline, which is governed by productivity, not bureaucracy. And really, we're R&D engineers. That's what we do here. We invent new processes, new products. That's what we do. So, yeah, you're right. That aligns very well. Okay. Within that context of R&D engineering, what do you think, what do you believe your job is? Not necessarily what your job description is, but like internally in your heart of hearts, what do you feel that your job is?
An R&D engineer, to me, specifically in the context of, mechanical design, which is the world I live in, my job is to understand as completely as possible all the nuances of some problem at hand, to filter and prioritize that information into a set of parameters which establish the boundary conditions for possible solutions, to deliver a range of practical alternative candidate design paths, and then to facilitate down selection to a chosen path, and finally to execute that chosen path to the very best of my ability. So it's not necessarily my job to define what we're going to do. My job is to give options to the people who are making decisions. Now, sometimes it depends on the context. I might be the one that actually winds up making that decision, but in the idea of the R&D engineer's job, that's that role. If I happen to be occupying additional roles, project management, what have you, those are separate domains.
And what are some of the tools that you use regularly to facilitate that role?
Well, obviously, the SolidWorks CAD and FEA, all of that part of building your own Legos to solve these problems is a very common thing. One tool that is not really taught in university, in my experience anyway, is tolerance stack-up analysis. It's absolutely critical to delivering quality products and often overlooked, unfortunately. It tends to get left to the very end of a project when it really ought to happen just as quickly as it possibly can. Being able to do that well and quickly is, I would say, a force multiplier for teams. The reality is a lot of people don't fully understand the manufacturing process of their designs. And so they will either overly constrain their parts in the assumption that if I hold really tight tolerances everywhere, that's going to be a better product. When in reality, the best part is no part at all. And the second best part is the one that is as loose as it possibly can be and still function properly. So that's going to keep your costs low. Anyway, soapbox, I'll get off of that one. Other tools that I often will make use of, as you alluded to in the intro, additive manufacturing is a passion of mine. It is a tool that has completely transformed the way design engineering happens over the last 20 years or so, especially now that some of those initial patents have expired and it's more accessible to the every person. We do things completely differently now than the generation previous has done. So I can't imagine doing my job now without the ability to rapidly iterate on designs in partnership with traditional manufacturing techniques as well.
Yeah, that's great. 3D printing has really opened up whole new worlds for a lot of us. I mean, we use it at work, of course, but we have a 3D printer at home as well, and we 3D print all kinds of things. My son just got in trouble for 3D printing plastic butterfly knives and handing them out at school.
Oh, brave new world.
Yeah, exactly. What are a few things that you do regularly as an R&D engineer that you wish you could just do 10 times faster? Probably, check me on this. Let me know if I'm off here, but I'm guessing there are things that you don't wish were 10 times faster because they're the things that bring you joy, right? You just love doing them. And if they were over 10 times quicker, that would be sad. But there are probably some other things that, man, if you could get through them 10 times quicker and get to the fun parts, you'd love that.
Sure. Well, I'd go back to tolerance analysis for one of those things that needs to be done quicker. It is painful and slow to do those correctly. To do a proper tolerance analysis requires a complete understanding of the total system you're working in. And so it's difficult to hand that off to other people and offload some of that responsibility. There are tools that can help, do that within a solid modeling context, which should help. But expertise is required to make the most of them. So I wish that was a faster and more integrated process. It's especially a problem when you have decoupled your design information from your tolerance information. And so as the design evolves, you have to make sure and go back and update all the tolerance information, or you wind up desyncing and it's a massive pain. You said things that I wish maybe wouldn't necessarily be 10x faster. I don't know that I would say any of it I would want to maintain the current speed on necessarily, even the parts that I enjoy, because if I got through them 10x faster, that just means I get to eat more of them, right? So if I can eat my ice cream 10 times quicker, I just get to eat more 10 times more ice cream.
Yeah.
In another manufacturing context, maybe supplier lead times especially have just become really difficult to predict, especially in this post-COVID world. Things that used to be, you could turn them around in a hurry in 4 weeks can be just ridiculous anymore, 16, 20, whatever weeks. I would love very much to be able to push a button and have that reduced down to days instead of weeks. I don't know that that's realistic, but I would love for that to be the case.
Yeah, you and me both. Thinking back over all the projects that you've completed in your career, and you've been working, I don't know, I'm guessing maybe, 15 years or something professionally, something like that?
Yeah, thereabouts.
Okay. What is one of your proudest accomplishments as an R&D engineer?
So looking back at the career I've had so far, probably one of the highlights I would point to is working with Disney Imagineers on the Be Our Guest scene for the Tokyo Disneyland Beauty and the Beast ride that was launched right into the middle of COVID, unfortunately. So I've never actually gotten to ride this thing. But for the Be Our Guest scene, I was personally responsible for half the animatronic designs in that room.
Wow.
And then responsible for the contractor effort on the other half of the animated props in there. And then the Imagineering team handled the hero figures, the Belle and the Beast. But everything else in there, I had a hand in, and that's, I think, really,
cool.
really special. One of these days, I'll get to take my family out to Tokyo and we'll check it out and see it in person. But
yeah, amazing.
One of the unfortunate things about being in R&D is that the timelines can be very long. And so things I worked on early in my career when I was at Honda R&D, Some of the things I touched there still aren't out yet, and it's been a long time. So I keep waiting. Like, yeah. So some of the things I've touched, I know they're coming, but I can't point to them yet. But that's one that's out in the wild, and I could say, yes, I did that thing.
Amazing. How long did that take? The Be Our Guest scene.
I worked on that for about a year.
Okay.
So it was it was a year of calendar time. It was about 2 years of professional experience,
as is often the case. Yeah.
Yeah.
Great. Okay. Well, what's something that you wish others would understand about being an R&D engineer that maybe even other engineers or engineering leadership doesn't fully appreciate?
The nonlinear nature of blue sky R&D, I think, is underappreciated. So a lot of the time when you're planning the scope of a project, you tend to sit down, you get your big piece of paper out, and you stick some swim lanes out there, right? You got your mechanical guys, your electrical guys, and we're just going to draw some arrows, and then we're going to get to the end of the project over here. We're going to forecast all this. The reality on the ground is we don't always know how to get where we're going. Hopefully we know where we are, and even more hopefully we know where we're trying to get to, but we don't often know what's going to happen along the way. And breakthroughs, you can't force them, right? You can only facilitate them. And by facilitate, I mean you get the right people together in the right place and give them the resources they need, and then you get out of the way. You turn them loose on the problem, and you see what happens. You give them the encouragement they need, and you bust down the problems that are in their way. But at the end of the day, it's going to take the amount of time that it takes to get through to that solution.
Yeah, I like to think of it as we're trying to go from A to Z. We can't see Z from where we are here at A. We might be able to see B. We might even be able to see C, but we can't see much past that. So we're going to take a few steps, see what we see, and hopefully we make our way to Z in the end. But like you said, if we could see Z from A, then it wouldn't be research, would it?
Exactly.
Yeah. Well, let me take a very short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. Today, we're speaking with James Rogers. James, what is one of your biggest frustrations as an R&D engineer, and conversely, what is one thing about being an R&D engineer that really brings you satisfaction?
Probably the biggest frustration I have working in an R&D context is something I alluded to a moment ago, and that's that it can be very slow to bring products to market. It's not at all unusual to spend years in development and then for whatever reason have the project shelved or launch into a completely different market than was anticipated when the project was planned. And so if you're basing all of your satisfaction or happiness in your professional life on successfully launching products, R&D may not be the right path for you. The reality is you don't get those hits that frequently. So it's important, conversely, therefore, to find satisfaction in all the smaller wins along the way. And that's what it is for me, coming up with a particularly elegant solution to a really thorny problem in the course of solving something in the towards a project. That's what I really enjoy.
Nice. How about one or two things that you think are most difficult about teaching others to become R&D engineers?
Two things in particular I think are difficult for people new to R&D to really grasp. And the first I would say is perspective. To really be effective in R&D, you have to be able to get way, way down in the weeds. You need to be able to see the roots of those weeds sometimes. But at the same time, you also have to maintain the bigger picture, right? If you are spending all of your time way down there in the roots, then you're going to miss some of the important nuance of things that are going on around you at the same time as well. The second thing is a passion for what you're working on. So it's not enough to you just come in and punch a clock in the R&D world, right? You need to care about the problem you're solving more than the paycheck that you're getting. Because realistically, these problems that we're working on are hard. They are too hard for the pay that you're going to get. Even in, medical device or aerospace or what have you, the compensation should come more from the satisfaction of a job well done and the problems that you're solving more than the paycheck, I think.
Yeah, well said. I was just thinking in my head that we all need to make a living, of course, but the real compensation, the reward is solving the problem, right?
Mm-hmm.
The paycheck is a bonus almost.
Yeah. Somebody asked me once, if you weren't being paid, would you still be doing this sort of thing? And they're like, yeah, I would be. I can't imagine a universe where I'm not solving problems like this. I might not be solving the same problems, but I would be doing the same sorts of things.
Yeah, for sure. People ask me sometimes, oh, when do you want to retire? And I always say, I never want to retire. Retirement, the traditional definition of retirement anyway, sounds so incredibly dull and boring. I think I would be miserable, right?
Yeah.
Give me more problems to solve. That I'll be happy doing that.
Definitely.
Well, if you could wave a magic wand and change one thing about your role, what would it be?
Well, I'm currently working in medical device, and it's absolutely necessary. I don't disagree with that part of it at all. But documentation is the bane of my existence. I don't think anybody who spends any time in especially in the medical R&D space would disagree with that. If everything could magically somehow self-document and report on the results of its own testing or whatever, that would make my life so much easier.
Wouldn't that be nice? Yeah.
But it can't be that way, right? It's not a necessary evil. It's just necessary. It's not evil at all, but it does have to get done.
I hope that with all of the AI inventions coming out, there will be some AI tool in the next 3, 4, 5 years that maybe doesn't do 100% of the drawings, but gets you 80% of the way there, right? And then you just have to kind of review it, maybe add a few things. That would be really nice.
Yeah. It will be interesting to see how that technology gets integrated into some things. The idea of SolidWorks auto dimension. Nope. Nope. Just nope. Don't even
That's
try.
A great way to describe it. Nope.
One of these days they'll get there, but it is not this day.
Yeah. We need to feed it a lot of gold standards, and one day we'll figure it out. All right. Well, you've kind of answered this question already, but let me ask it in a slightly different way and see if we get any different response. When you started your role as an R&D engineer, did you understand what it meant to be in the field of research? And how has that understanding evolved over time?
When I graduated from college, I thought I knew what it was to be in R&D. My senior design project, I led our Baja SAE team at the university. And that was a big thing to do. And so I thought I was all ready and gung-ho to go when Honda gave me the call and said, we'd like you to come design off-road vehicles for us as well. And I got there and found out that while I did have an appreciation and some level of understanding, it was incomplete. And so I now, over the course of my career, have developed a much better appreciation for the importance of all the other roles in the course of a project. Particularly in medical device, it's very much a team sport. There are things that have to be done that I would absolutely be miserable if it was my job to do them. The quality guys and girls in particular, I don't know how they do that job. I would not be happy in that role, but they seem to love it. And I'm glad for them that they do, because that has to happen. But that does not bring me joy. So, I'm happy to have those people on my team. And then I think maybe this is just part of being more mature as an engineer or person in general, but a greater willingness to present alternatives without getting married to any particular concept, and not taking it personally if your favorite concept isn't the one that's selected to move forward with. There are often factors outside of your control or awareness that influence the direction on a project. And so not getting bent out of shape if somebody doesn't pick what you wish they would, that's an important thing to appreciate as well.
That's a great segue. Speaking of these mindsets, right? Allowing for other ideas outside of your own to be pursued. What are some of the other attributes or mindsets that are really important to being a successful R&D engineer?
I think curiosity, cross-discipline is really important. For me, I'm a mechanical engineer, but I also have a certain amount of software and electrical knowledge. If you point me at a circuit board and ask you to completely debug it, I'm probably not your guy, but I can solder components on there and I can fumble my way through analyzing some code. Being able to understand what's going on outside of your own area of expertise, it facilitates discussions that need to happen to move the whole project forward. That overall, nothing is beneath me to understand idea, that's really important, I think. Along with that, let's just try it mentality, right? Being willing to be enthusiastic about challenging the unknown, that's also critical. There is, well, I guess it ties into the third thing I'd say. It's no fear of failure. If you are constantly worried about, well, what if this or what if that? And yeah, what if? What if you don't? Sometimes we have to go out there and break something to find out where the limits are.
Yeah.
And you want to find that out in testing before you launch your product and figure out, well, crap, shouldn't have done that. Failure isn't, unless you refuse to learn from it, failure isn't failure. It's an opportunity for growth, an opportunity for improved understanding. And so being able to embrace that, make the most of that opportunity, and advance your own understanding and the greater understanding of the team and the company as a whole, that's critical. And I mentioned this one already as well, but a passion for problem solving in your domain. You got to have that.
Yeah. I like what you said about, well, I like what you said about all of it, but thinking about being willing to try things that may or may not work. There was a project I did a long time ago, probably 10 years ago or so, and we're stuck on a certain aspect of it. And the customer came in and said, hey, what if we try this thing? Let's try ABC. And I'm thinking to myself, I'm the engineer here. Why don't you let me solve the problems, And super hubris, right? Just a horrible way to think about it.
Mm-hmm.
He was the customer, so we said, okay, we'll try it. In my head, I'm thinking, there's no way this is clunky and big, and there's no way this is going to work. Lo and behold, that was the thing that worked. So being willing to just try something. And if it doesn't work, that's okay too. Learn from it, right? What can you learn that you can apply to the next iteration?
Mm-hmm. That humility, I guess I would tack that on there as well for the list. Very often, I think, especially new engineers come into the field thinking that they understand things more than they really do, particularly when it comes to the manufacturing side of things. Until you've been in those shoes for a while, definitely listen when somebody in a manufacturing role tells you, I don't know about that. They've been there. They know what they're talking about.
Absolutely. Yeah. Or the technicians who are the ones putting these things together. They're boots on the ground.
Mm-hmm.
Yeah. All right. Well, just maybe one or two questions more, and we'll kind of wrap things up here. Let's pretend that it's 3 years from now, and you're looking back on just reflecting over the progress you've made the past 3 years. What needs to be true for you to feel happy and satisfied with the work that you've done as an engineer?
My personal development goals right now are tied to broadening that software and electrical cross-discipline expertise that I talked about earlier. I'd like to get a little bit better at some of those things, as I think they would enhance my ability to do my primary job more effectively. But I think overall, where I see myself right now, I'm in a position where I can influence and develop those around me, peers, and maybe even influence up and down. I would like to see 3 years looking back that the engineering department where I'm at currently is much stronger now than it was then. We have enhanced our expertise and our processes and all of that across the board, and we're all better for it. But, at the end of the day, if I can look back and say with no hesitation that every day I gave it my best, then that'll be enough for me to feel satisfied. I don't have to have, earned 10 patents or something like that tacked onto the end of my LinkedIn profile to think, okay, well, I made it. Now, that'd be nice. If all the things I'm working on have launched and all the patents have been granted and all of that, that's all frosting on the cake, right? But if I've done my best, I've done my job, that'll be enough.
And no one can ever take that away from you, right? There are a lot of things that can be taken away, but the knowledge that I gave it my all, no one can ever take that away.
Absolutely.
Well, James, this has been delightful. Is there anything else that we should talk about that we haven't hit on yet you think would be useful or helpful for those listening to hear?
I would just shout out all of those who have maybe a checkered past, academically speaking. Don't be afraid of your past and what it might, what you might think would hold you back from. I did not have a particularly easy time getting through university, or really school in general. I found out recently that I think that was probably tied to untreated ADHD type of stuff. And so there's a whole rabbit hole we could go down on that one. But I would say past performance is no indication of future results. It's what you choose to do with the hand you've been dealt is up to you. And don't let yourself be held back by past failure. Embrace that, like we talked about before. It doesn't have to be just in a engineering context, but it can be personally as well. I don't care how many times you had to take calculus. At the end of the day, you earned that degree, right? And so now you're out here in the world. Do something with it.
Very well said. I think engineering school is quite a bit different than engineering, practically speaking, as a profession, and they were definitely, I was like you, I did not find school to be easy or for me, very enjoyable. One of the happiest days in my life was when I finished like that last paper I turned in and I was done. Wow. What a great feeling that was.
And then we went back for a master's, right?
Well, that's what I turned in my master's thesis, and that was the last thing literally that I had to do for anything for school, and I was done. But yeah, the profession of engineering, I think, is quite a bit different than the schooling for it, which is not to discount the schooling, because it does teach you how to think like an engineer. It gives you that logical thought process, which is super important. But as far as like the day-to-day activities that you're actually doing, school is not necessarily indicative of what you're going to be doing in the workforce.
Definitely.
Well, James, I sure appreciate you taking some time to talk and share your insights and your experience. How can people get a hold of you?
Well, you can reach out to me on LinkedIn. You can find me linkedin.com/in/RogersJ3, or you can send me an email. My independent consulting firm, which is me, is protodevinfab@gmail.com. I think you can get there through my LinkedIn profile as well.
Excellent. Great. Well, thank you again, James. I sure appreciate you being on the show.
Well, thanks very much. Have a great one.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.